It didn't work. Oh my goodness, boys and girls, that balloon was hard to blow up. I'm Miss Lisa, and we're here at Fayette County Public Library today with a show called Science Isn't Scary. Today we are going to be talking about the states of matter. Did you know that matter is what makes up our whole world? And matter is made up of teeny tiny things called atoms. And it depends on how these atoms bond together as to whether we have a solid, a liquid, or a gas. Let's talk about each of those just for a minute. If we could pretend that this is a gas molecule, let's put just one atom inside there. And as it bounces around, look at that. It has all that kind of space to go everywhere at once. That's because gas does not take up any particular space. It's just everywhere. Now, you know that sometimes gas has an odor. If somebody is cooking apple pie in the kitchen, you can smell that all the way into your bedroom. That's because that gas is going through the air, because it just goes everywhere. It's not contained into one space. Our next state of matter is called a liquid. Now, liquid molecules have quite a few atoms in them, but they still can move around. Think about the liquids that you have in your house, boys and girls. I bet you have juice and milk and water. You might have some syrup or honey. All of that is a liquid. Those molecules, those atoms, they just bounce around a little bit. You know that liquid can flow. Okay, it can pour. You have some that don't pour as fast, but it's still because the molecules are not really tightly packed in together. Now, if we talk about our last state of matter, which is a solid, the atoms inside these molecules are just packed in super tight. Okay, and they don't wiggle or move at all. Don't you know that solids have a definite shape and a definite size? They don't change shape or size very easily. Now, heat might change them, and a big heavy force might change it, but solids are called a solid because the little molecules inside there just don't move around. They're so tightly packed together. Now today I want to show you 3 awesome little experiments. One talking about gas, one talking about solids, and one talking about liquids. I've got some really cool things, boys and girls. Do you think this is going to be our last one? But over here I have a can. Do you think with science I can collapse this can without really even touching it with my hands? Oh, you'll just have to wait and see what we're going to do with that. Go ahead and turn the heat on just a little bit and get it ready to go. Follow me over here, boys and girls. I have a water bottle that has a little bit of liquid in it. Now, it's not water. And I have a balloon, and it has a little bit of a white powder in it. So, remember I've told you that a gas doesn't take its own shape. It just goes anywhere that it wants to. So we really can't see a gas, but we can watch what happens when it reacts together. So we're going to take this liquid and this solid, and it's going to react together. And if it's done right, boys and girls, it should blow up the balloon. The gas that's created through the chemical reaction should blow up this balloon. Hopefully better than I tried to blow one up at the beginning of the show. Okay, are we ready? We're going to put that in there, and look, boys and girls, that balloon is blowing up. That liquid and that solid created a gas, and it blew up the balloon. Isn't that cool? We could see that reaction. So that was a gas. Next, let's talk a little bit about liquids. Liquids. You know, we have all kinds of liquids in our house. Here I have some honey, I have the Dawn dish soap, I've got some cooking oil, and I just have some water that I've actually colored green so that we can see the differences. Now, liquids can all pour at different speeds. If they pour real slow, we say they are more dense than the others. So out of these, which one do you think, boys and girls, is the most dense? Which one pours the slowest? If you said honey, you would be right. So I'm going to open this up, and honey is very sticky and it's very thick and gooey. Watch me as I pour it. Okay? It pours rather slowly, and it's quite dense if we compare it to other liquids anyway, right? Okay, so there's our honey right there at the bottom. Let's see, what about Dawn? And as we move it around in the container, we can see it sort of sticks to the side. But liquids don't have any shape of its own, do they? They take the shape of their container. Now this liquid will pour pretty quickly. And if we pour it in here just right, it ought to sit on top of the honey because it is less dense than the honey. Can you see the layers? Isn't that cool? This is already boiling, so I need to turn that down. All right, we don't want that boiling yet. All right, so we have our honey, and then we have the Dawn dish soap. Next, we have our oil. Now, do you think it's going to stay on top? Let's see what happens. Look at that, boys and girls. Each item has been less dense than the other. So we have our honey and our Dawn dish soap and then our oil. The last one was the water. You think the water is going to stay on top, or is it going to go somewhere in between? Let's see what happens when I pour the green water in. Okay, if you notice, the water actually went below the oil because the water is a little bit more dense than that oil. That oil is going to float on the top. So this shows you, boys and girls, that different liquids have different amounts of density. That's really pretty cool. All right, our final thing over here, we're going to talk a little bit about solids. Remember, solid has its very own shape, its very own size, and you can't switch it around very often. All right, or very easily, unless you have some extreme heat or you have some extreme force. Now, let me just turn this back on just a minute so I can get it exactly where I want it. In this container I have behind me, we have some other solids. I wanted to talk just a minute about some other solids. Solids are broken up into all different kinds of categories. Look at my little monster. Do you know what he's made out of? He's made out of cloth. Now you know that cloth and fabric, it can't change shape very easily, can it? Unless you cut it or burn it. What about this? What's this made out of? This is plastic. Again, this is a solid that has its exact same shape and size. It's hard to switch it around. Here I have a hole puncher. Boys and girls, you know what this is made out of? This is a solid called metal. And again, it has the same shape and the same size, and it doesn't change very easily. Paper is another category of solids. This paper, we could tear it up and break it, we could burn it, and that would be a way for it to change shape. But if I would just set it on the table, it would stay that way forever. Here's a little puzzle piece, boys and girls. This is made out of wood. Wood is another category of solids. My crayon is made out of wax. Wax can change its shape, or we could break it, but again, you have to use force in order for it to change its shape. That's one of the definitions of solids. Here we have glass. Okay, so our different solids, boys and girls, are glass and fabric and plastic and wood, metal, wax, paper. I bet you can find some of these solids around your house and put them into different categories. All right, are we ready for the really cool thing? Can we use science here, boys and girls, to take this solid and collapse it without my hand physically touching it? All right, so the little bit of water that was on the inside is boiling. I am going to grab it and put it into the ice water. Watch what happens. Woo! Wasn't that that cool, boys and girls? Okay, so what happened was that cold air and that hot air, it just imploded that can. Poof! Isn't that cool? Science is so much fun. Boys and girls, I hope you liked this little demonstration today about solids, liquids, and gases. I hope that you maybe find some of these things around your home and just name them. They're a lot of fun. I'm Miss Lisa, and we're here at the Fayette County Public Library. This was another episode of Science Isn't Scary.